Hi guys, my name is Jonathan Lee, and today I'm going to be talking about Rust lifetimes. So first I'm going to start off with a main function. Inside the main function, I just want to test to make sure it works, so I'm going to type some stuff like, I don't know, let's say a, over here I'm going to let a equals to 4. Yeah, so it prints and it works. Good, I want to make sure Rust works. Okay, good. So what are lifetimes? I'm going to show you. So we have let a. What if I did this? Let a, create a scope, and here I say let b, create a scope, let c, create a scope. And then, or just these two are good. And over here, I'm going to set a is equal to 4, b is equal to 6. Alright. That works, of course. And then I'm going to do a function, max. Alright, so what this max function does is it's going to take two references, x and y. And if x is bigger than y, it's going to return x. It's going to return the first reference, and else it's going to return the second reference. So over here, I'm going to say c is equal to max of a and b. I want to see which one's bigger, and I want to print c. But right now, I know for certain that c is going to be a reference. So I'm going to dereference it and print it. So here's what I'm doing incorrectly. So I want this to be a I32, and I want B to be an I32. I want this reference to be a X is going to be a and I32, and Y is going to be an and I32. Oh yeah, by the way, I need to let C. Okay, cool. Oh yeah, right. Over here you need to do a return type. I'm going to return a reference to an I32. Oh yeah, this is exactly what I want to say, okay? See, it says expected lifetime. Okay, this is where I want to start off, okay? So, first off, I have the main function, right? If the main function has an a, I'm going to create an a scope, and then set the a, and then let b, set b scope, and here c is going to say, I want the maximum of a and b, okay? So, max is going to return a reference. It's and it's going to compare a and b, and going to see, wait, actually, this is a problem. I need to return the reference of a. Okay, so max is going to take two parameters. It's going to take the reference, which is the memory address of a, and it's going to take the memory address of b. And this is max, right? And then if you have, which one's bigger, okay? So if you have, wait, so not the memory address, you want to dereference it. Yeah, so it takes a and the reference of a and b, and then it's going to dereference, and which is going to get the value. So this is the value of x, this is the value of y. This is the value of a, this is the value of b. If the value of a is greater, it's going to return the reference of a. If the value of b is greater, it's going to return the value. It's going to return the reference of b. Okay, and that's going to be c. And so c is going to be the memory address of a and b, the one with a bigger number. But it's going to be the memory address, right? So over here, when you're going to print it, you're going to dereference it. So you're going to take the memory address and you're going to find what the value is. This is what your code should. That's the logic behind the code. And when you run it, of course, it has an error, and the error says expected lifetime parameter. So it doesn't understand, the Rust compiler doesn't know if these two things will live long enough. It doesn't know if, because it's worried that if it returns the reference to X as C, it's worried that this thing will die out really quickly, right? It's worried. So it needs to know the lifetime of this. And so to provide a lifetime, you do a -a, and then here you would do a -a. Here you would do a. So most people will just bash it with lifetime. So it'll just go something like this, and then it'll print, and it's like, okay, it works like that. But they don't really understand what it means, what it truly means. When they're doing this, they're essentially saying that, okay, max is gonna, you're gonna create a lifetime, okay? Lifetime variable is gonna be called a, and x is gonna live a that long, and y is gonna live a that long, and what you're gonna return is gonna, it's gonna live a that long, which is kind of not true, right? So a actually lives this long, and b actually only lives this long, right? So a lives within the whole main function, and then it dies. B lives within the whole A scope, like this scope, and then it dies. And so they're not the same. And so if you want them not to be the same, you'll say that for this lifetime, you're going to call this A. And for this lifetime, you want to call it A, B, right? So let's call this B. And so you have two lifetimes now. You have A and you have B. And are you going to return A, or are you going to return B? Which one are you going to return? You're going to return a shorter lifetime, right? You're going to return a shorter lifetime. Okay, so what's this supposed to mean? Okay, well, actually, let me change this a little bit just to make it look nicer. I'm just going to make it nicer. Okay. So let's just say that let A over here. Let's just say that this is the case. I just want to make it look nicer. Okay. It's going to change the code a little, but it's going to be more easy to understand. So okay, let's change it up a bit. Okay, so this is the lifetime for A. Okay, see, within this scope is where A lives and dies. The lifetime of B is going to be within here. Okay, this is where B lives and dies. So over here, you're telling the compiler, okay, A is going to live this long, and B is going to live this long, right? So this reference to A, this reference is going to work as long as it's, this reference to A is going to work as long as you're using it within here, and this reference that you return for Y, like if you return Y, it's going to work as long as you're within here, okay? That's cool and dandy. And do you want to return A's reference, or do you want to return B's reference? So here's the deal. This A lifetime is longer than the B lifetime. Why do I want to return B? I want to return B because I just want to be safe. If I return B, then I know it's the B is supposed to correspond with Y, right? So if I return B, if I tell the compiler this is going to return a B lifetime, then if I return this ampersand Y, it's going to live this long. That's fine. If I return ampersand X, X is capable of living this long, but I'm just going to say, just in case, I'm going to limit it to living this long. That works. If, on the other hand, I were to change this to an A, right? If I were to change this to an A, then I'm going to say, then that's actually a problem, because if it returns ampersand X, then it's basically returning the reference to A, right? And the reference of A lives A that long, right? So A, it lives this long. That's fine. But what if it returned the reference to Y? If it returned a reference to Y, this thingy over here, this thingy, only lives this long. But I'm telling the compiler that it's actually living this long, which is a problem, right? This thing only lives this long, but I'm telling it that it's going to live this long. Which means if down here I were to access ampersand B, or I were to access it somehow, the program would have issues. So that's why I'm going to pick the smaller lifetime, just to be safe. But here's the thing, when I run it, it's gonna fail. And the reason why it fails is because it's gonna treat A and B as two independent lifetimes. It's gonna say, okay, you have your A, you have your B. They're totally separate in the world. They're not related. One is black, one is white. Like, they're totally different colors. They're like opposite. They're like totally different. And if you return B, yeah, that this will work for this. But what if returned X? How the heck is X related to B? So to do that, you have to specify that the A lifetime contains the B lifetime, right? This way, you're telling the compiler that no, A lifetime is actually related to B lifetime because the A lifetime contains B lifetime. When you do that, then it works. Right, so what this code is saying here is that the A lifetime is this lifetime, okay? A lifetime is this lifetime, and this A lifetime, it's big. It's a big lifetime, and this A lifetime contains the B lifetime. And for B lifetime, you're just saying it happens to be a B lifetime. And so when you have A and B and you return B, then the compiler says, okay, how about ampersand X? If it returns ampersand X, you're returning the A lifetime. But A lifetime, already, it's so big, it's bigger than the B lifetime. And you're returning a B lifetime. So it's going to expect a B lifetime. So if you're returning ampersand X, which is the A lifetime, is going to be bigger than the B lifetime anyway. So that's totally fine. And if you return the ampersand Y, it is the B lifetime. So that's totally fine too. So there's that. And so what you're essentially doing here is you're telling the compiler the structure, how long these variables live. And you can actually do multiple of these if you really wanted to. Right, so you can create another one and you can say let C is equal to, so you can say A is equal to 1, B is equal to 2, C equals to 3, and then you can create another one, like, and then over here you can say that let B is equal to max of and A and B and C, and you want to print out D, right? You want to print out the maximum. If we were to do it like this, it shouldn't be that hard. You would just define you would just have X, Y, and Z now. So Z is the C lifetime, I 32 again. And you want to create multiple lifetimes. So over here, it takes in the A lifetime, takes in the B lifetime, takes in the C lifetime. Right? So yeah, you have your A lifetime, you have your B lifetime, you have your C lifetime. Which one you want to turn? Well, you have the A lifetime, which is this, the B lifetime, which is a little smaller, and your C lifetime, which is the small list. You want to return the smallest lifetime, right? So over here you have X, Y, and Z, and then you want to return. Okay, let's say you do some stuff over here, right? You're like, okay, it returns ampersand Y if X is the biggest. If X is big, like, okay, it's gonna if X is greater than Y and X is greater than Z, I want you to return and X. Let me check. I think that's correct. Okay, so else if Y is bigger than X and Y is bigger than Z, then you want to return Y. And over here, saying that else, which is if Z is the biggest, then you want to return Z. See that? And then you want to deal with the lifetimes again. You're going to say A contains the B lifetime, but B contains the C lifetime. And what are you returning? You're returning the C lifetime. You want to return C lifetime. And when you run it, it should work. Right? It should work. And over here it says, oh, you don't need the parentheses. Well, yeah, you probably don't need the parentheses, so you can just delete the parentheses if you want. So anyway, the important thing that I want to note here is that with lifetime subtypes, oh yeah, I forgot this. this video is actually lifetime subtypes. Okay, that's referring to here. So when you define lifetimes A, B, and C, a compiler does not know that they are related in any way. So it'll just treat them as independent ones. To get the compiler to know that the lifetimes are related, you can say that A contains B. Like A is a group that contains a smaller group B, and B is a group that contains C, right? So this colon syntax shows which lifetime contains which other syntax, right? So the bigger ones on the left, smaller lifetime on the right. And that's how you would do it. Yeah, that's my code. Yeah, so anyway, I hope you enjoyed this video, and if there's something confusing about it, you can leave the comment. You can leave a comment down below, because this is lifetimes are actually one of the challenging things about Rust. I hope I did a good job explaining, and yeah, if you have any questions, you can just just comment below or something. Just, but I hope this video was helpful to you, and if you liked it, feel free to like it, and I'll see you next time.